Types of software. You have used much software like MS Word, MS Excel, Logo, MS Paint, etc. Have you ever wondered what software is? How is software created? Who creates them? In this lesson, we are going to discuss about different types of software and languages used to develop these software. Software concepts. Software is made of many programs that work in coordination with each other to perform a single task. Each of these programs is a set of instructions that achieve a common outcome. In other words, many instructions make up a program or procedure, and many procedures make up software. Examples of software include word processor, spreadsheets, animation tools, drawing tools, presentation software, operating systems. Let us take example of word processor software to understand this in detail. A word processor is a software to assist us in processing documents. To do this, the software must enable us to create, edit, update, format, and save documents. For each of these tasks mentioned here, a separate program or procedure is written. Each procedure, say for saving the document, will have many instructions in it. Depending upon its function, software can be divided into three categories: system software, application software, and utility software. System software. System software is the interface between hardware and the user. This interface is required because computer hardware understands only binary language, that is 0 and 1. We humans speak many languages, but not the binary language. System software converts all human instructions into machine understandable language and vice versa. Based on its function, system software can further be classified into operating system. Example: Windows 7, Windows 8, Windows 10, Linux, etc. Language processors. Example: compiler, interpreter, C, C++, Java. Device drivers. Application software. Software that enables us to do specific tasks like handling documents, creating presentations, editing images, creating audio and video files, etc. are called application software. It does a single task and nothing else. So, word processors cannot create presentations, image editors cannot work with databases, animation software cannot handle spreadsheets, etc. Examples: Photoshop, GIMP, MS PowerPoint, Oracle, etc. Utility software. Application software that helps system software in carrying out its functions is called utility software. It is an overlap between system software and application software. There are many types of utility software. Some of these are backup software. It makes a copy of your files and stores it in another part of the hard disk. It can be used to recover data if your system crashes. Examples include Acronis TrueImage 2017, Amanda, and Borg Backup. Antivirus software. It secures your system against malicious software. Examples are AVG, McAfee, Quick Heal, etc. Disk defragmenter. It assists in optimum utilization of disk space. Files are usually stored in contiguous locations on the hard disk. However, if contiguous locations are not available, they are broken down or fragmented and stored in non-contiguous locations. The disk defragmenter utility scans the disk for space and joins together the defragmenter files to be stored at contiguous locations. This increases reading and overall processing speed for the files. Disk compressor. It compresses or squeezes the files so that more and more information can be stored on disks. Examples include 7-zip, IZARC, WinRAR, and PZip. Computer languages. As you know, computers understand only zeros and ones. The language of zeros and ones is called the binary language. Since the invention of computers, computer scientists have developed languages that can be understood by both humans and computers. Let us see what these languages are. Machine Level Language, First Generation Language. Machine Level Language (MLL) has a set of instructions defined as a string of zeros and ones that can be understood by the computer. The instructions are directly executed by the CPU the way it is put by the user. These are the characteristics of machine-level language. Machine-level language is machine-dependent. Each computer has its own set of instructions depending upon its architecture. Detailed knowledge of computer architecture is necessary to write programs in machine-level language. Time taken for execution is very quick because instructions are directly executed. Very difficult to remember the binary instructions. Every instruction has to be a combination of the predefined instruction set. So, very few applications can be developed using machine-level language. Assembly Level Language, Second Generation Language. Assembly Level Language (ALL) has a set of mnemonics that are used to give instructions to the computer. Mnemonics are English words that have a predefined meaning in assembly level language. CPU converts these memories into MLL before executing them. Mnemonics introduce a level of abstraction so that programmers are able to remember instructions more easily. Characteristics of assembly level language are: it is easier than machine level language. It is machine dependent. So, each system has its own assembly level language. Detailed knowledge of computer architecture is required to write ALL programs. Examples of assembly level languages are COBOL, Fortran, etc. High Level Language, Third Generation Language. High Level Language (HLL) is very similar to the English language. They use words, numbers and symbols that we use every day. Characteristics of high-level language are: it is very logical and hence instructions are easy to remember. It is machine independent, so the same program or software can run on different machines without any changes. It is easier to learn than first and second generation languages. Use of HLL has popularized use of computers and increased its application manifold. Example of high-level languages includes C, C++, Java, etc. Language processors. As discussed, computers and humans speak different languages. Converting human instructions into machine-understandable instructions is an important function of system software. Software that converts human instructions into machine-understandable language and vice versa is called language processors. Program that needs to be converted to machine-level language is called the source code. Machine-level programs obtained after conversion from higher-level programs are called object code. There are three categories of language processors. Assembler. It converts assembly language programs into machine-level language program. Interpreter. It converts one instruction of source code into object code at a time. When that instruction is executed, the next instruction will be interpreted. If there is an error, the instruction will not be interpreted till you correct it. Compiler. It converts complete source code into object code at one go. This process is called compiling. A compiler also gives a list of errors which you should correct and recompile the source code. The compiled object code can be executed anytime you want without needing the source code. Compiling a program makes it faster to execute as compared to interpreting. An interpreted program needs to be interpreted every time you execute the program. In case of compiler, you compile the program once and run the object code as many times as you want.